This is Lesson 3, Disaster Recovery Strategies and Autoimage Replication. This is the third lesson in this course. In this lesson, we'll review different disaster recovery strategies. We'll discuss autoimage replication, how to configure it, monitor it, manage, and maintain it. We'll talk about how to prepare for government disasters and for disaster recovery of the net backup infrastructure. And finally, we'll talk about protecting the MSDP catalog. This is the Disaster Recovery Strategies topic. A robust disaster recovery strategy involves planning for the loss of both data and the net backup infrastructure. And so we make sure that we have adequate backups of our data and adequate copies of those backups. As the old saying goes, if I only have one copy of something, it doesn't exist. So we make sure that part of my DR strategy is moving copies of my data to an off-site location, which could be done by a number of methods, by doing vaulting of tapes, which could be done by replication or other disk-to-disk duplication. Then I also make sure that my disaster recovery strategy incorporates plans for recovering the net backup infrastructure, either by using catalog backups or by using other methods, such as catalog replication. When it comes to making multiple copies of my backed up data, there's a number of different strategies that I could use. One would be duplication after backup. This is sort of the traditional strategy. Looks like from the slide here that we're using a tape-based strategy. So backups get done during the backup window, and then later on there's a duplication window. Traditionally that would be during the day. When I do tape-to-tape duplication, I get a second copy, and that second copy can be sent off-site. This helps because it doesn't require any additional hardware for duplication. I'm using the same tape drives that I used at night for my backups. It also gives me a feel-good that those backups I made last night are readable. Since the duplication was successful, it means that my initial copy was good, which is why some folks will vault their originals rather than vaulting the duplicates. Another strategy is to make multiple inline copies. That means that rather than doing duplication after the fact, I'm simply creating multiple copies while the original backup is running. NetBackup can create up to 4 simultaneous copies using various tape or disk destinations. And the advantages here is that it can make for a more aggressive recovery point because tape copies can immediately be vaulted, disk copies can immediately be replicated as soon as the backup is done. Potential disadvantage here is that the speed of the backup will be driven by the slowest media if I'm writing to different media types. Another duplication strategy is disk staging, where the backup is initially done to a disk device and then later on duplicated, in this example, to tape. Now this has got a number of advantages to it. The backup performance and the restore performance should both be good if we're using high-speed disk devices. In particular, the individual file restore from a big backup image is much snappier from disk, and I still get my copy on tape. And using disk staging, I'm able to keep fast tape drives streaming because that duplication from the disk device to the tape device is usually pushing one big tar file across a SAN or another high-speed connection. So I can usually maintain a data rate fast enough to keep the tape drives streaming. So lots of advantages to using this strategy. Many duplication strategies will involve vaulting of tapes, meaning that I have a tape copy which is created on site, maybe through duplication, and then I'm physically shipping that tape cartridge off-site to a vault for it to be stored in case it's needed for a disaster. The advantages here are that I can do this without any additional hardware if I have a duplication window that's separate from my backup window. The downside here is the time that's involved in doing the duplication and in physically moving the media, so that'll affect my recovery point objective. This kind of a setup where I'm shipping a lot of tapes off-site and then possibly rotating them back on-site once the backup images expire is ideal for the NetBackup Vault option, which allows me to automate the duplication and also provides a number of very useful reports for tracking my media and where they are. A more disk-centric duplication strategy would be the use of optimized duplication and/or replication, where I've got tape out of the picture now and all of my duplication is going disk to disk. Now the terms duplication, optimized duplication, and replication, different backup vendors use them a little bit differently, and that can kind of muddle the picture here a little bit. When we use these terms within NetBackup, when we use the term optimized duplication, we're talking about the ability for a disk pool or a backup appliance to duplicate data to another pool or appliance without necessarily needing to go through a NetBackup media server. And in most cases, these disk pools or appliances will support deduplication, which means that almost all the time when we're talking about an opdupe, we're talking about only the changes moving from one disk pool to another. So if I opdupe a full backup image, I'm not pushing the whole image across the wire, just the stuff that's changed since the last backup. So it's very efficient in terms of the amount of bandwidth it's using. When we use this term optimized duplication, or opdupe for short, we're talking about duplication within a NetBackup domain, with disk pools that are all under the control of one master server. When we use the term replication in NetBackup, we're usually talking about a cross-domain duplication, where we're taking backup images and we're replicating them from one NetBackup domain to a different master server, a different NetBackup domain. And that's the Autoimage replication feature that we're going to discuss in much more detail later in this lesson. And in many cases, we're not going to necessarily use one duplication strategy for every piece of data in our environment, especially when we start talking about operations at an enterprise level. We may be taking a combined approach where we use different duplication methods for different types of data. And this might be a very formal, very structured approach if I have set up different tiers of service, where I say there are some data in my environment, the most critical stuff. I'm providing a very high level of service by doing disk-to-disk backups with replication. And then there's kind of a second tier of data where it goes initially to disk, but I'm duplicating it to tape and shipping a tape offsite. And maybe below that, another tier of data where backups go directly to tape. And which tier I'm classifying data is affects its recovery point and its recovery time objectives. And this may be a very formal process where I have written service level agreements that define exactly what level of service you get, depending upon what tier your data has been assigned to. There are a number of ways of accomplishing that within NetBackup. Storage lifecycle policies are particularly attractive when we start talking about setting up standardized tiers of service, because I can have many backup policies using a single lifecycle. And so I can basically create one lifecycle, one storage plan for each tier of backup service that I plan on offering. And the lifecycles will guarantee that I meet that level of service. This is the introduction to Autoimage replication topic. Autoimage replication, often abbreviated as AIR, is the automatic replication of backup images from one NetBackup domain to another using storage lifecycle policies and supported disk pools. Essentially, AIR is two operations. It's an optimized duplication followed by a fast import. Because whenever we're talking about AIR, we're talking about two different NetBackup domains. And so what we're looking to accomplish here is what you might call a Site A, Site B backup strategy. I have two NetBackup environments. They're active, protecting data, and I want them to cover for each other. I want one NetBackup domain to be able to send backup images to the other one, and for them to be restorable if that first domain ever fails. This prevents the need to have a colder DR strategy where I would have to rebuild a master server and do the whole catalog recovery process for every backup image. This way, some or all of my backup images can receive better treatment through AIR. You're generally going to get much better recovery time objectives. Now, AIR can support a Site A, Site B strategy like I was talking about. It could also support a many-to-one model, a hub and spoke, some folks might call it. And the nice part about this is it's highly automated by using storage lifecycle policies. This slide shows an overview of the Autoimage replication workflow. As you can see, I have two NetBackup master servers, Server A and Server B, and each one is running a separate NetBackup domain. So in the source domain, the first thing that happens is backup jobs are done to a disk pool that specifically supports the AIR feature. When the backup is complete, then the source disk pool will replicate the backup images to the target domain, and that replication will be an optimized duplication. The whole backup image isn't going across the wire, just the stuff that's changed since the last backup. And then in the target domain, a alert gets fired off that notifies the target master that new data has been received, and a fast import takes place where the metadata that NetBackup needs of what these files are inside this backup image is imported into the NetBackup catalog. Now, it's important to stress that this is a fast import. It's not like the kind of import, a traditional import you do from tape where we spend hours and hours indexing and cataloging. We don't need to do that in this situation because the necessary metadata, the NetBackup image catalog.f files, are appended to the backup image when it is sent from the source domain to the target domain. So it's a trivial operation to take that metadata and copy it into the catalog there. It usually takes less than a minute. And then once I have that data in the target domain, I have it for safekeeping in case I ever need to restore it, in case there's ever a disaster in the source domain. And then if I wanted to make additional copies, I could do that as well. I could use this image that I sent over to the target domain by air and, for example, do a tape out. So I have another copy on tape. And now I've got that copy on tape at a remote site without having to physically ship the media there, which is also nice. Configuring auto-image replication requires the use of supported disk pools in the source and the target domain, and the use of storage lifecycle policies. And so in my source domain, I'm going to have a storage lifecycle policy with a minimum of one backup operation and one replication operation. In the target domain, I'm going to have another storage lifecycle that has a minimum of an import operation. And if I wanted to have additional duplication operations in addition to the import in the target domain, that would be okay as well. With auto-image replication, we typically establish replication pairs, where we have a source domain that is replicating data to a target domain. Now, it's possible to have multiple targets, so that one source domain is replicating data to multiple target domains, for an extra level of protection. The default behavior for air is the source domain is always going to replicate to all of the target domains that are configured in the disk pool properties. Now, it's possible that I may want to have a little more control over this so that from lifecycle to lifecycle, I may replicate to some or all of the target domains that have been configured. In this example here I have on the slide, one source domain, two target domains, and for this particular lifecycle, I want to replicate data to target domain 1, but not to target domain 2. That level of control was not originally offered when auto-image replication was first debuted back in NetBackup 7.1, but it was added later as a separate feature called targeted air. With targeted auto-image replication, I get that extra level of control where I can specify a specific target master server's domain. So note that targeted air is considered a separate feature. This is important when you're checking the hardware compatibility list and you're checking your disk pool to make sure that it's compatible with air. Remember that air and targeted air will be listed separately. Veritas pools and Veritas appliances always support both air and targeted air, the same way Veritas always supports all OST features. Third-party OST appliances might or might not, or they might support air but not targeted air. Again, you got to be careful with the HCL and check up on that. This is the Configuring Auto-Image Replication topic. This slide lists the auto-image replication requirements and prerequisites. Your master and media servers require NetBackup 7.1 or later to support air. Targeted air requires 7.6 or later. The disk pools used in the source and the target domain need to be compatible with each other, which usually means they need to come from the same vendor. And the minimum version required for different Veritas solutions is shown on the slide here. Build It Yourself MSDP, Pure Disk, and NetBackup appliances are all supported. Open storage vendors have the option to provide support for this. Which vendors do and which vendors don't, and which appliances support it and which ones don't. Those details are all found in the latest version of the NetBackup hardware compatibility list. In terms of licensing, AIR uses the Data Protection Optimization license, which is the same license that dedupe pools use. So essentially there is no additional license for AIR. AIR requires the use of a supported dedupe pool, and dedupe pools require the DPO license. To configure Autoimage replication, I first configure replication pairs, one source domain and one or more target domains. For Veritas MSDP pools, I'm going to go into the credentials for the storage server to add replication targets. For other supported third-party OST vendors, I'll configure replication pairs following those vendors' instructions. Then I'm going to go through and verify the trusted master servers in the host properties. I'll verify the replication parameters in the NetBackup disk pools, and I'll create two lifecycle policies. I'll create the lifecycle in the target first, which is going to include at a minimum an import operation, and I'll create an SLP in the source, which includes at a minimum a backup and replication operations. Once that's done, I'm ready to go. I can create backup policies that use the source storage lifecycle, and those backup images will be replicated using AIR. We'll use a Veritas MSDP pool as our example. And so my first step in configuring Autoimage replication, I go to Credentials and then Storage Servers, and I locate the storage server for my source MSDP pool. That will be listed as a pure disk server type. Right-click and say you want to change, and then in the Change Storage Server Properties box, select the Replication tab, and then click the Add button to add replication targets. The second step in configuring Autoimage replication is the storage server configuration, and it will depend the exact steps I follow here whether or not I'm intending to use targeted AIR. If I have a very simple setup where I have one source domain and one target domain, then it would be sufficient to just specify the target storage server type and the target storage server name here. If I did want to make use of targeted AIR, where I can select which of multiple targets to use for each lifecycle, then what we're going to do is we're going to establish a trust relationship between the source master server and the target master servers. And so in that first box there where it says target master server, I can select a trusted master server from the list if I have already configured these trusts. Configuring the trusts can be done from the master server host properties, or you'll see there's an option to do it right from here. So if I've never done it before, I can say add a new trusted master server. A pop-up box opens up where I can specify the host name of the trusted master server and the credentials for that host. And so I'm putting down the username and the password to administer that host or appliance. And then after doing that, again, same thing, target storage server type and target storage server name. And then down towards the bottom of the Add a Replication Target window, whether I'm using standard AIR or targeted AIR, I'm going to provide login credentials to the Replication Target storage server. Now, be careful not to get confused here. You know, when I was establishing a trust between master servers, I had to use a username and a password to get access to that host. Down at the bottom of the window, where they're talking about the login credentials to the storage server, that's the credentials to the dedupe pool itself. So if this was an MSDP pool that I built myself, that's the credentials I'll be entering there. If this is a NetBackup appliance, then I can get the password for the dedupe pool from the CLISH interface to enter here. To confirm that the target storage server was added successfully, I examine the Change Storage Server Properties window, and I should see the target storage server name and target storage server type listed just in this example over here, where I'm again using a Veritas MSDP pool. We mentioned that if you're using targeted air, you'll be establishing a trust relationship between your source master server and one or more target master servers. Now that can be viewed by going to the master server host properties in the source domain, and then going to the servers tab, and then to trusted master servers. Here are the master servers that I've established a trust with. So in this example, just one target master server. And you'll notice that I can add additional trusts from here, which would be exactly the same as if I added it from the storage server properties window. This step here of going through and confirming that the target master server can be seen here is not mandatory, but it is another confirmation for me that the previous steps were accomplished successfully. Another confirmation for me that the replication pairs have been set up successfully. In the source domain, I go to Devices and then Disk Pools, select the MSDP disk pool that was going to be my source for air, right-click and select Change, and I should be able to see in the replication column that this pool is configured as a source for replication. Note that, as the slide points out, it is very likely that that won't show up when I initially hit the window, but I should click the refresh button, and after clicking refresh, that word source will show up in the replication column. So far, all of the configuration steps that we've discussed take place in the source domain. Here's an example of something you can do in the target domain to verify that the replication pair has been set up successfully. So here I am in Devices, Disk Pools for the target disk pool. Right-click and select Change, and I should see that this disk pool is configured as a replication target. And again, I will probably need to hit the refresh button in order for that to show up. The next step is to create storage lifecycle properties. And I'll begin by creating the target SLP first. So in the target domain, I'm going to create a storage lifecycle policy that's going to contain a minimum of an import operation. Prior to the advent of targeted air, in the backup versions prior to 7.6, it was a requirement that you used identical lifecycle names and classifications in the source and the target domain. In 7.6 and later, targeted air is available, and one of the things that targeted air allows you to do is to specify a particular lifecycle for the import operation. It's still a good practice in a simple air setup where you're only going to have one source and one target to have identically named lifecycles. And so I give this lifecycle a name, the same one I'm planning on using in the source domain in most cases. And then I specify that import operation, and note that that's going to use a disk pool in the target domain. And the retention is going to be set to target retention. And that means that it is the retention that's specified by the source that dictates how long it's kept. So if the source says keep this for a month, the target domain will keep it for a month. Notice the verbiage there is a little counterintuitive. We're calling this target retention, but in reality it is the source replication operation which is determining how long the target domain keeps the data for. And then when it comes to any subsequent operations I may want to do, for example, it looks like we're doing a duplication to tape here. That duplication to tape could have a fixed retention, or it could use the target retention. That's optional. But as a best practice, the import operation should always use the target's retention to guarantee that I am storing this data at the target domain for an amount of time that satisfies the service level agreement. The source domain is counting on the target domain to keep this data for a certain period of time to be in compliance. Next, I create a storage lifecycle policy in the source domain. And again, I'll typically give this an identical name to the lifecycle I created in the target domain unless I'm using targeted air. And a minimum of 2 operations here. First, we create a backup operation that targets the source disk pool's storage unit. And then I create a replication operation. The replication can either do replication to all target disk pools, which would be the first option, the default option, or I can use targeted air, which is the second option. targeted error allows me to specify a target master server and a target import SLP. Also, in that replication operation, I'm choosing a retention period. In this case, it's a month, retention level 3. Remember that will be important because that's basically my instruction to the target domain for how long I'm expecting that they're keeping this data for me. This is the monitoring auto-image replication topic. This slide takes a look at the jobs that are created in error operations. So in the source domain, I see the backup complete. Once the backup is completed, the replication will kick off, and by default, this replication will happen a few minutes after the backup is completed. And then in the target domain, once the image has been duplicated over, the target domain will notice it's there and then do an import operation, which will show up in the target activity monitor. Once the import operation is complete, which is usually a very fast operation, if I have any secondary operations, such as a tapeout configured in the target lifecycle, they'll kick off. Now notice with these additional secondary operations, I'm assuming they'll kick off pretty much immediately. That's the default behavior in SLPs. But there is the ability to set duplication windows in lifecycles that might control when secondary operations happen. Here's a closer look at those jobs in the source domain. So we see job number 32 is the original backup job. Job number 34 is the replication job. And if you take a closer look at the details there, you can see messages in the detailed status that indicate the replication is happening. It tells you the IDs of which images are being replicated, and it indicates the target as to where the images are going. Here's a closer look at the jobs in the target domain. So we see job number 16 was the import operation. And taking a closer look at the details of that job, we can see which backup images are being imported, and we can see what their origin is. Helps us confirm that everything is working as expected. Once that fast import is complete, if there are any secondary operations that are configured in a target lifecycle, they can then begin. In this case here, job number 18 is a duplication to a Media Manager storage unit that was configured in a lifecycle. This is the managing and maintaining auto-image replication topic. When we choose to make error part of our disaster recovery preparations, one of our considerations is what sort of restores will be possible with this data that I have replicated from one domain to another. Now, Veritas recommends using the source domain for restores if possible, but if something has happened where that's not possible, let's say that the client still exists, but there's been a failure of the net backup servers in the source domain, then we can just go ahead and configure the client in the recovery backup domain and restore directly to the client. The biggest thing I'll need to do there are some permissions changes, because by default the client in the source domain wouldn't normally have the right permissions for media servers in the target domain to restore data. That's easy enough to fix. Or if it's been a more serious problem where this client no longer exists in the source domain, well then I could create a new client, same host name presumably, in the recovery domain, and then restore data directly to it. Or an alternative would be to do an alternate client restore. Rather than rebuilding a whole new server, maybe there's an existing server in the target domain which can host this data, and I only need to restore some files or restore one instance of an application. The steps to do this are the same as they would be for any other restore. Just remember that if you want to use GRT, granular recovery technology, you do need an application instance that's compatible in the recovery domain. Cascading replication is possible. So in this case, I'm doing error from a source domain to a target domain, and then that target domain is replicating the data to a third domain. And presumably, because of my topology, it was not practical to simply have domain 1 simultaneously replicate to domain 2 and domain 3. And so that's okay, you can do that. The only limitation that you wind into here is that it is the original owner of the data which specifies the retention. And so the data at domain 3 is going to use the same retention level that was originally specified in domain 1. Now, if that represents a problem, there's an example in the next slide here where we can work around that. In this example, we want to do cascading error, but we want to vary the retention level between domain 2 and domain 3. So what I've done is I've used error to replicate data from domain 1 to domain 2, and then in domain 2 I've done a standard duplication. Now once I duplicate that data, domain 2 is now the owner of that copy, and it will dictate the retention when the data is replicated to domain 3. And that's the best way to think about it. Think about it that the owner of the data, the original owner, dictates the retention. This is a little bit clunky, but it is a viable workaround. As we mentioned, in addition to using error for a Site A, Site B data protection strategy, I could also be using this for a many-to-one, often referred to as a hub and spoke. And so in this case, I have one domain that's my main DR domain for multiple remote sites. And a lot of times folks would call that the bunker site. And so my two remote domains, domain A and domain B, I've got an MSDP pool, build it yourself, 64 terabytes in domain A. I've got a 5230 appliance in domain B, and I'm using error to replicate data to the bunker site, domain C. And at the bunker site, I have installed a large capacity, quarter petabyte NetBackup 5330 backup appliance. The big thing to remember here is just that your disk pools must be compatible in order for error to be successful. In this case, I'm using all Veritas solutions, so that's good. Generally speaking, the source and target have to be from the same vendor. Also, be careful with your NetBackup versions. Ideally, the NetBackup version should be the same in all domains. That'll give you the best possible compatibility and the fewest headaches. If it's not possible to upgrade everybody simultaneously, upgrade the targets for error first. Replicating data from a lower NetBackup version to a higher one is much less likely to cause issues than doing it the other way around. You really should avoid using error to replicate data from a higher version to a lower version in case changes to the catalog cause you issues. Storage lifecycle parameters can be customized, and some of these settings will have an effect on error. So if you're looking to make changes to the way either the replication operation or the import operation is handled, here we are in master server host properties under SLP parameters. And the parameters that we have highlighted on the slide here show settings that will particularly have an impact on error. Now, when changing these parameters, be careful that you're changing them in the correct domain. That's an easy mistake to make. Anything that has to do with the behavior of replication operations should be configured in the source domain. Anything that has to do with import operations, parameters should be adjusted in the target domain. Remember that the different master servers will have their own catalogs and their own SLP parameters set. In terms of troubleshooting tips for error, a general knowledge of troubleshooting storage life cycles is very helpful. And like we were saying before, any troubleshooting you're doing, make sure you're doing it in the correct domain. Do investigation for replication job issues in the source domain. Do investigation for import issues in the target domains. And some general things that you can check here. Verify that the target storage server is accessible from the source domain. Check your NetBackup versions. Again, ideally, these should be identical. If they can't be identical, make the source a lower version than the target. If you're doing third-party OST with a non-Veritas vendor, then there will be OST plugins installed on the media server, both in the source and the target domain. Make sure they are the correct version. You have to consider the OST plugin and possibly the firmware of the appliance that you're using. And make sure you have verified with the hardware compatibility list that you're using a vendor that supports this feature for the firmware level and the appliance model that you're using. The nbstl util command is very helpful in working with storage lifecycles and therefore very helpful in working with error. I can use this command to get information about images and what their status is, whether they've been processed completely or not by storage life cycles. So for example, I can view here a list of all images that are pending import. I can list image, replica, and replication operation records. I can see the status of incomplete copies or a summary of incomplete images. This information is extremely useful in troubleshooting error, and it's a level of visibility as to what life cycles are doing and what they have done that's not really visible from just looking at the activity monitor. In addition to collecting information using NBSTL-util, I can also manage images from here. So for example, I can activate or deactivate SLP operations for a particular image or a particular lifecycle. I can cancel pending duplication operations. I can repeat an SLP operation on an image or recreate a copy. These are extremely useful commands to be able to use. Remember that SLPs are programmed to make copies, and they are relentless in doing so. When an SLP has been configured to create a copy of an image, it will continue trying to do that forever until that copy is created. As you may remember from the administration class, images are not allowed to expire if there are still pending lifecycle operations. Now, it may on some occasions be necessary to cancel or abort these operations, and NBSTL-util is useful for that. OpCenter is also a very useful place to collect information. You see under Storage Lifecycle Policy Reports, I can view SLP status and SLP backlog. A lot of the same information I can get from the NBSTL-util from the command line, I can get in a nice, easy-to-process graphical form from here. Looks like we're looking at an example here of the SLP backlog report, a particularly useful one for seeing if I'm keeping up with my duplication. Storage lifecycles make it very easy to duplicate data. Remember that one of the steps in getting up and running with this is to ensure that I have enough time and enough bandwidth to get all of my data replicated before it's time to do the next cycle of backups. Otherwise, you can get into a situation where it's time to do tonight's backups and I haven't finished duplicating all the stuff from last night because the link between the source and a target domains is very slow. And that's an example I can literally see here in this report as the amount of pending duplication just increases every day. I've either got to find a way to allocate more bandwidth to this, or I'm going to have to be a little more conservative in how much data I'm moving via error. Remember that in many cases, it may not be possible to use error as your one and only DR solution, where everything gets errored from one domain to another. It might be that only the most critical backups receive this treatment, and then other data has to be protected using other means. Here's a look at the SLP status report, showing me the high-level status by default of storage life cycles for a particular master server. And you'll see that using the links in this report, I can drill down to get a little more detailed, where I can see specific life cycles and get a lot of detail about the status of their operations. This is the Protecting the Net Backup Infrastructure topic. As we've mentioned, a robust disaster recovery strategy must plan for the duplication and proper preservation of both backup data and of the MyNet backup infrastructure. And you can see that the number of required steps and the speed of recovery depend upon the techniques that I'm using. Purely tape-based strategies where I'm trucking tape cartridges from one location to another generally result in the longest recovery times. When I start incorporating faster technologies like disk-to-disk replication, I start seeing that more aggressive recovery time objectives are possible. We've talked a lot in this lesson about duplicating and replicating backup images. Now when it comes to my net backup information, when I'm doing DR preparation, make sure that I have a robust method for making sure that critical net backup metadata, i.e. the catalogs, is available at the recovery site. I might do that by clustering, which would provide for true high availability, or I might do it by catalog replication, or I might do it by performing regular catalog backups. make sure that I'm familiar with DR procedures, and make sure that whatever method I'm using, that I test it regularly. At a minimum of once per year, I conduct a DR drill and put all this to the test and make sure I actually can recover data as I think I can. One of the considerations during my DR planning should be, will I have the same number of media servers at my recovery site that I did in my original production site? If so, then great, nothing more needs to be done. But in a lot of cases, I may not have the same number of media servers available at the recovery site as I did in production. And if so, I should plan for this in advance. Master server host properties, restore failover, allows me to specify failover media servers. And it's basically just a 2-column list here. If the media server in the left column is not available, use the media server in the right column instead. Remember that the default behavior for NetBackup is that the media server that did the backup is the media server that it's going to be looking for to do the restore. If I know that media server is not going to exist in my recovery site, plan ahead for it. Now, an alternative, or something you can do if you're stuck in a pinch where we didn't plan ahead for it, is to do a force restore media server. And what this means is a different set of settings here where I'm doing a media host override. I'm saying for any restore that would normally use media server A, use media server B instead. And notice the difference between the two. In the failover media server, NetBackup looks for the original media server first, and if it doesn't find it, it uses somebody else. That's a non-intrusive configuration. Whereas the media host override is saying, stop using this media server for restores, don't even look for it, don't even try, use this other media server instead. This slide reviews the catalog backup process. During the catalog backup process, we see a parent job, and then we see a series of child jobs. The first child job stages the NBDB, basically does a dump to the staging area, to the paths that's called out on the slide here. And then the second child job comes along and backs up that dump of the NBDB to tape or to disk, whatever storage unit is configured in the policy. And then the third child job comes along and backs up the remainder of the flat configuration files, the image catalog and the backup policies. Every time a catalog backup job runs, a disaster recovery report will be created. It'll be written to a path that's specified in a catalog backup policy, and optionally it can be delivered by email, which is a great way of getting this information to your DR site. Remember that this little DR file that is generated is the first thing that the catalog recovery wizard is going to ask for if you go to recover the catalogs. So I need to ensure that this is making it from my source domain to my recovery site. Now, emailing it is a great way to do that, and some folks will go so far as to use a non-corporate email system, webmail like Hotmail, in case the corporate email is down because of whatever disaster happened. That's kind of a cute thing to do if it's allowable. Sometimes security restrictions won't allow us to do that. But whatever method I use, the important thing is that it's got to get there. Email is a great way to do it. Some folks who have a lot of security requirements may wind up using a much more physical method, such as writing it to a thumb drive and including it in every box of tapes that you ship. Catalog backup policies also allow you to specify some policies as being critical. This is optional. You don't have to do this if you don't want to, but it can shave a little bit of time off your recovery, particularly in tape-based recovery operations. What I'm doing here is I'm specifying a list of backup policies, and the media that is required to restore the most recent full backup of the clients that are members of these policies will be included in that DR report, in that email that gets generated. So basically I'll have a list of the media I need to recover my most important servers. And so if I've got a situation where my backups are on tape, and the tapes are stored in a vault, and they have to be physically shipped from the vault to the recovery site, this lets me get a head start on the process. Here's the first batch of tapes I'm going to need, get them moving right away. This slide shows a high-level overview of recovering the NetBackup environment, and this is pretty much a cold recovery, where I have to rebuild everything from scratch. And so it all begins with the master server. I have a master server I'm going to build that's going to have the same operating system and the same host name that it did in the original NetBackup environment. I'm going to install the NetBackup software, same version I was using in production, and then I'm going to do any device configuration that may be necessary. For example, if I'm doing a recovery from tape, I've got to set up at least one tape drive. Then I can recover the NetBackup catalogs, restart the NetBackup services, and then I'm ready to go ahead and restore other data. I can immediately start doing restores using the master server as a media server, or I can recover other media servers if I've got the hardware available. Media server recovery, as you can see, is pretty easy. There's no catalog recovery for media servers. It's just a matter of reloading a minimal operating system, give it the same host name it had in production, and reinstall the NetBackup software. The use of bare metal restore can shave a lot of time off of my recovery because I can use BMR to do a one-button recovery where I push out operating system and the most recent full backup all in one action. I can do that for my media servers. I can do that for my clients. The only host that I really can't use it for is my master server. The master server has to be recovered using traditional methods, and I'm assuming here in my example that my master server and my BMR server are co-located on the same host. So once that host is online, I can use BMR to recover everyone else. An alternative to the traditional procedure of rebuilding a NetBackup master server in the case of a failure would be to use replication. And so in this case here, I have my main master server, and then in the recovery site, I have a standby master server, and that has a replica of my NetBackup catalogs that's being continuously updated. There's no method within NetBackup to do this continuous replication, but there is support for enterprise-grade replication solutions. And what I mean by that is it has to be a robust replication product that supports write order fidelity. So any good enterprise-grade replication product, such as a Veritas Volume Replicator, would work fine for this. Now, generally speaking, if I'm doing replication, I'll want to do full catalog replication, so I'm maintaining all data, including tape and device data. It is an option to do partial catalog replication, where, let's say, for example, I replicate only the image catalog and the policies, but not the device information, but that's going to add additional steps to the recovery. This is a high-level overview of restoring a failed master server, and this is using the traditional method, the catalog recovery method that we were talking about earlier, and we're doing a complete catalog recovery here. And that guarantees that all of the NetBackup catalogs, the NBDB and the configuration files are recovered, so all image, policy, client, tape, device, and BMR data is all coming back. Now, if I'm looking for the fastest possible recovery of my NetBackup servers, I could look at clustering. Media servers cannot be clustered, but master servers can be. And of course, master servers are the server that's hosting all of this critical catalog data. By setting up a cluster for my master server, if the master ever fails, my other node in the cluster can come online and resume backup activity, and this would be the absolute minimal interruption of service. You know, with a local cluster, you could be talking about just minutes of interruption before you're back online again. And if you wanted to, you could use global clustering technology to have a cluster that stretches across multiple sites, possibly some distance away. Clustering's a great option. You know, it's pretty much all advantages. There's no real disadvantage to talk about other than an increase in total cost of ownership, because you have to be supplying a clustering solution. NetBackup supports a number of enterprise-grade clustering solutions, such as Veritas Cluster Server, Microsoft Cluster Server, Sun Clusters. The cluster compatibility list, which is available from the NetBackup support site, specifies in detail which solutions are supported. And there's another document, a master server high availability guide, which outlines the steps to go through to cluster your master server. And some limitations to think about: conversion of an existing server to a cluster, or going from a cluster to a non-cluster. Those are not supported unless you engage consulting. All nodes must be running the same operating system and the same NetBackup version. Multiple master servers in a single cluster, like an N+1 setup, is not supported. This is the Protecting the MSDP catalog topic. Every media server deduplication pool has two types of information that's stored in it. The actual data that has been deduplicated, and an MSDP catalog, which is the metadata, the fingerprints that were used to identify duplicated data and that are critical to recovery of that data. Normally, the MSDP catalog is a separate path, although it is possible to have data and metadata on the same volume in a build-it-yourself MSDP setup. In a NetBackup appliance, they'll always be on different volumes, which is a better way to do it, because then you can transact data and metadata asynchronously and typically get better performance. Now, this does mean that there's some critical metadata here that's stored on NetBackup media servers that are not part of the catalogs on the master server and not part of catalog backups. Now, the traditional solution here is that this is not a big deal, because when we protect data on our media servers, we do it by using opdupe or by using AIR, which means that data and metadata is duplicated from one location to another. So in my recovery site, I have everything I need to do the recovery. But there was customer demand for an increased level of robustness. We're not thinking just about the DR scenario here. What about smaller issues? Like if for some reason we got some corruption in this MSDP catalog, we'd like easy recovery from that. And maybe we would like the ability to do a separate backup of this catalog just for extra peace of mind. And so NetBackup 7.7 provides two levels of MSDP catalog protection. There is a shadow catalog, which is maintained online, and there is an offline catalog protection option by using an MSDP catalog backup. The online MSDP catalog protection runs automatically and is always active. And there are multiple copies of MSDP catalog metadata created by using shadow copies and journals. This is stored in a separate directory than the rest of the MSDP catalog, and if corruption is detected, automatic recovery takes place. And so this provides for a self-healing capability in the MSDP pools. If the minor corruption gets in there, the pool can literally repair itself with no action required by the administrator. You may not even notice that there was ever a problem. The normal housekeeping just took care of it, and that's great. Now, since these additional copies of the metadata, these shadow copies and these journals exist, if we wanted to add another layer of protection, we could do offline MSDP catalog. And that means that we're creating an MSDP catalog policy, which we do using a special utility called DR control. The DR control utility provides for the protection of and the recovery of the entire MSDP catalog. Here's a visual look. Here's an MSDP storage server. Might be a build-it-yourself MSDP, might be a NetBackup appliance. They're handled the same way for this purpose. I have a storage path where my actual deduplicated data is stored, and I have a database path. And it's in that database path where a shadow catalog and a journal are maintained for online recovery and self-healing. And it is that shadow catalog and that journal which can be protected using an MSDP catalog backup policy. Now, notice although we're referring to this as an offline protection, we're just pointing out that it's not something that's happening automatically. You don't have to take your MSDP pool offline or pause backups or anything like that, in order to protect this data. But what you do have to do is you do have to create an MSDP catalog policy, and you do have to schedule it to run at regular intervals, like you would with any backup policy. Note one difference with NetBackup appliances is that appliances will have an MSDP catalog created and inactive by default, whereas in an MSDP pool you create yourself, this policy just doesn't exist. You create it. Here's an example of configuring an MSDP catalog backup with the DR control utility. I configure the MSDP storage server as an additional server in the master server host properties, and I run DR control for each non-appliance MSDP storage server. Remember, appliances will automatically have this policy created and inactive. MSDP catalog policies are always inactive by default. When I want them to run, I will activate them and go into the schedule and set a frequency or calendar and a start window, again, just like any backup policy. And notice the recommendation down there from Veritas: use a separate policy to protect the MSDP catalog for each MSDP storage server. Don't combine multiple storage servers on the same policy. You can get into issues where the location of the data may be slightly different on different storage servers, and that causes problems. In this lesson, you learned about disaster recovery concepts for NetBackup images and for NetBackup catalog data. You learned how Autoimage replication works, how to configure it, monitor it, and manage it. You learned how to prepare for common disasters and plan for disaster recovery, and you learned how to protect the MSDP catalog. This concludes Lesson 3.